Welcome to PEEPanEIP, the one and only series dedicated to learn about Ethereum improvement proposal and network upgrade. As we are heading towards Pectra upgrade, Ethereum cat headers hope to bring an overview of each proposal for your learning. So if you're interested in Ethereum improvement proposals, stay with us. Hello again, this is episode 132 and I'm your host Pooja Ranjan. Today we are here to talk about EIP-7685 General Purpose Execution Layer Requests. Documented in April this year, the proposal defines a general purpose framework for storing contract triggered requests. The proposal is currently in review status. To explain what is the general purpose bus and why developers consider them important to be included in the next Ethereum upgrade, we are joined by the author of the proposal, Matt Garnett. Welcome, Matt.
Thanks a lot, Pooja.
For people relatively new to our channel, Matt Garnett is an EIP editor, author, and co-author of multiple EIPs, a developer at execution client Geth. He is very kind to take out time to talk about Ethereum specs and improvement proposals in different blockchain forums. I'm happy to share that about 4 years ago, Matt Garnett was our guest on PEEPanEIP to record the first episode of the series. It was great talking to you then, and I hope people will enjoy today's talk as well. So thank you, Matt, for joining us again. And before we get into the proposal, could you please maybe share about yourself and journey in the Ethereum space?
Yeah, sure. Thanks for that introduction. That was very kind. I can't believe that was 4 years ago. That really doesn't seem that long ago, but shoot, that's a long time. Yeah, so I've been in the ecosystem since 2018. I got started working on an application at Consensus and just realized that even if we did our job as application developers, that the protocol wasn't really ready to handle super successful applications. And so around the end of 2018, going into 2019, I started working more on protocol related tasks. And some of the first things I worked on was, at that time we were looking into Ethereum 2, it was called. And the team I was on was specifically looking into phase 2, which was how are we going to do execution in this new Ethereum environment with many different shards and maybe different type of execution using WASM instead of EVM. So I spent about 1.5 years working on that, thinking about the future, but also just learning, sort of building my experience and understanding how the protocol worked and how people in the protocol work. And then after that, after phase 2, part of Ethereum 2 sort of started to fade out and we started focusing on a bit more near-term things. We got involved with account abstraction. That must have been around 2020. So I think, around 2020, I started getting a lot more involved with close to the protocol type of work. And so we were looking at doing account abstraction in the protocol. I looked into becoming an EIP editor because at that time we were starting to have a lot of EIPs. We wanted to push through this account abstraction EIP, and I had no idea how EIPs worked or how one made an EIP, how one pushed an EIP through, all of these things. And so I started getting involved in editing around then. And at the time, Micah and Alex Perigzazi were pretty active editors, and they sort of mentored me and got me up to speed a bit about how the EIP process started working. And I think you had been working on the EIP process for at least 1 year, maybe 2 years at that point. And the cat herders was kind of coming about. And I think we sort of have all been growing together the last few years, which has been super fun. But so I did that until about 2022, and at that point I was talking with the Geth team a lot, and I had worked quite a bit in the Geth repository for our account abstraction work, the type transaction work. I did some work on EIP-7685 for Geth, and at that point it was kind of like, okay, I'm writing a lot of PRs for EIPs into Geth. Maybe it would make sense if I was more involved with the team. And so I started talking to the team and it seemed like a good fit. So I ended up joining in 2022. And I've been there for the last 2 years, where I've got the opportunity to work on the last 2 hard forks, as well as many other protocol related things like testing or specs. And that's how we've kind of ended up here with 7685 or 7685. Too many numbers now. But yeah, I think we can break into it at some point, but I think it'll be clear why I wrote this.
Sure. I mean, this is pretty interesting background about you. And yeah, it doesn't seem like it's been 4 years, but the effort towards making the process even better and sharing information about proposals, because as you said, this is 7685. That means like, so many proposals have came in between, not that 7,000 plus. I think it is somewhere around 800, but that's still a very good number,
Yeah.
very big number.
Mm-hmm.
So thank you so much for all the work over here, and I look forward to learn more about this new proposal that we are expecting with the Pectra upgrade. So without further ado, let's peep in.
Sweet. Okay, so let's look at EIP 7685. So what is a request? This is something that hasn't existed in the blockchain really before. So at least not something that we formally defined. And so I just want to define for the viewers here, what do I mean by a request? We'll get into the technical definition later, but in general, I'm talking about this act of asking for something on the execution layer to be recognized on the consensus layer. This is sort of a new thing that it is coming about because of the separation of these two layers, execution and consensus. And historically, we have had some requests. Specifically, when the Beacon chain launched, we had this deposit contract. This was a type of request. I want to request on the execution chain, which at the time was the only live chain, that I want to create a validator on the consensus layer. And so we didn't call it a request, but a deposit was a type of request. And as we're seeing with some of these EIPs for Pectra, there are quite a bit of EIPs that fit this request mold for Pectra, and there's a possibility of even more. So in Pectra, there's 3 specific ones that are at the forefront that are very likely to go in or have already been decided to go in. And the first is, like I mentioned, this deposit request. We want to now synchronously communicate deposits from the execution chain to the consensus chain. Today, the way the deposits go from execution to consensus is the consensus layer is following a list of logs from the execution layer chain and sort of parses out the deposits from those logs. 6110 will modify this a bit so that deposits are passed directly to the consensus layer via the engine API. So that's the one example that's existed for a while. In the Chapella, we had so we introduced withdrawals, and withdrawals were not really a request in the sense because it was something that you had to send directly to the consensus layer. There wasn't the ability on the execution layer to take a message originating in the execution layer and push it back to the consensus layer. So that was kind of like a consensus layer transaction, which is sort of like what you saw whenever people were setting their withdrawal credentials to execution layer addresses. It was more of a consensus layer to execution layer message. Now with Pectra, we are wanting to do a bit more with this administration of validators. And so 2 ideas of things that we want to have is, part of 7002 is exits and withdrawal requests. So an exit request would be on the execution layer. The execution layer address, which controls my validator that I've set as my withdrawal address, can now make a request to say, I control this validator and I would like to exit this validator. So that's going to be a new type of message that's originated on the execution layer. It's authenticated on the execution layer and it's sort of sent over to the consensus layer. As an extension of that, with this MaxEB proposal 7251, we'll also want to have a withdrawal request where you can sort of withdraw ether that is greater than your currently set effective balance for consensus, essentially. And this is similar to this consolidation request, which is the 3rd type of request, which I don't think has officially been accepted for Pectra yet, but it's something that we're continuing to discuss and generally feel it's an important part of MaxEB. But what does MaxEB do? The TLDR is it allows you to combine many validators into one validator public key. So if you had 10 validators, you could put all of the funds of those validators into one public key and have the same consensus weight as you would have with your 10 validators. To make that operation happen, you might want to initiate that consolidation request on the execution layer. The alternative would be for the consensus layer to process the consolidation request. You could send a message on the consensus layer. The consensus layer implements some more message formats like they did with the withdrawal credential setting, and they could consolidate it on their end only. We are thinking of adding this as a request in the execution layer just because it's simple. It lets us do things more programmatically. A lot of people are using the execution layer withdrawal credential, and so the authentication scheme makes a lot of sense. So these are the types of requests that we already have thought of for Pectra. There's the possibility of many more requests come in the future. So there's an idea called rainbow staking. Barnaby has a really nice post on ETH Research about what rainbow staking is, but the really simple explanation is that in the future, we might have many different types of entities acting in the consensus protocol. And so you might have a very lightweight entity that's doing just pure validation. You might have a heavier weight entity doing signature aggregation, block building. You might have some committees trying to do some of the censorship resistance, inclusion lists design. There are a lot of roles that you could have in the consensus. And so there might be more things that we want the execution layer to be able to request of this consensus layer. So 7685, the EIP we're talking about here, sort of opens the door for more of these future things, in addition to making what we have today a bit more tenable. So I described a lot of what these requests are, but maybe the issue is not super clear to people. Why is there an EIP to define a general purpose request? I have told you about 3 different requests that we're considering for Pectra. What is the point of having a general purpose bus for communicating those? There are 3 main things that came up as we began implementing these requests. So if you look at the numbers, 7685 actually came after all of these. So we had already spec'd 6110, 7002, 7251 without 7685. And as we began implementing it, we found that the implementation was unnecessarily complicated. For one, because there are many different call sites where we're trying to pass block headers around or block bodies around. We would have to update all of them. This made it difficult to prototype the individual proposals because we had to then choose which proposal would be based on the last proposal. Because the ordering of the fields matter a lot, it's not easy to in Git have a diff that touches the exact same place in the code. You create a lot of conflicts whenever you try to merge those things. And then in general, this doesn't really scale well. If we believe there's a future where we want to add another 2, 3, 4, 10, 20 requests. So as I was implementing this, I sort of thought it would be nice if we had something that looked like the typed transaction model. If you look at the type transaction model, EIP-7718, versus what we have with 7685, it's almost identical. The serialization scheme is the same, having the type prefix, having the data. I took a lot of the ideas from 2718 and tried to just apply them to this request format. It's a little different because it's not really user originated. The requests don't come from outside the chain. They're generated generally from execution of a transaction, but many of the encoding ideas are the same. So this is why we thought to do 7685. So 7685 is not required to do the requests. It's something that we just wanted to do to simplify our lives today, simplify things for the future possibly. Like you can see by the numbering, 7685, again, it came after all of these proposals. So it was possible to do the proposals as they were written. I think that in general, the execution layer devs felt this was a good thing to do, and so we ended up changing around what we were planning to do to DevNet 0 to add 7685 in. People were generally happy. The alternative would be to have a substantial re-architecting of clients, and that was not something that people felt was important right now. All right, with that said, let's look at what the actual specification for 7685 is, because I've sort of been beating around it this whole time. It's really straightforward. So straightforward, I fit it all on a single slide. So there's 3 things that we need to define. The first is, what is a request? So like I said, it is very similar to how 2718 defines a 2718 transaction. It is a type concatenated with the request data. The request data makes no assumptions about what the data looks like. For all of the requests in Pectra and for the foreseeable future, it's likely that request data is RLP encoded. just because that's how execution layer clients tend to encode data and decode data, and we have very good tooling and experience using those tools. So request type plus some RLP encoded data. That's how that tends to be. Then we define what the request list is. So the request list is the concatenation of all of the requests that were found to be in the block. And the ordering of the requests is defined to be by the request type for the inter-request ordering. So you can see here in this example, it goes request with type 0 and then request with type 1. And then inside type 0 request, we have two requests. We have one which is index 0 and one which is index 1. So the ordering is first you order all of the requests based on the outer type, and then inside the type, each individual type can define its own ordering. It tends to be that the individual types order based on like execution priority or execution ordering. So for the deposit contract, I think this actually is the type for the 6110. It's type 0. So let's just say for deposits, if you have 100 transactions in the block and 10 of them make a single deposit to the deposit contract, in the request array, you would have the type 0 request first, and then inside it, you would order the deposits based on the first transaction executed that was putting a deposit in, and then you would go to the next transaction that put the deposit in, and then the next. So it would be in time ordering, basically, inside the block. For more things like the exit/withdrawal requests, those are done by some sort of system calls to a contract, and the contract is maintaining a queue, and so the ordering is sort of already defined based on how things are popping off the queue. But the takeaway for 7685 is that each type gets the opportunity to define its own ordering inside its type. Okay, and then request root. So then the request root is simply the Merkle-Patricia tree root of the requests. And the way that we compute the Merkle-Patricia tree root is the exact same that we do with transactions. So for the transactions, we take the list of transactions, then we insert them into a Merkle-Patricia tree by index. So the first transaction, I would insert into the tree at index 0. Second transaction, I would insert into the tree at index 1. We do the same thing for requests. After you insert them into the tree, you can compute the Merkle-Patricia tree root. That root is what would go into the block header. So the block header is extended with a new RLP element, and that element is the hash. It's exactly the request root. And we also extend the block body, where the block body now has the request list. So in the block body, you now have your transactions, your empty omers list, the withdrawals, and we concatenate the block body with the requests. So that's the full spec for 7685. It's very simple and flexible, and it's designed in a way that it's compatible with future request types. We're trying not to be too imposing about what the specification should be, and instead keep it open for the future types to define what they need to define. There are some suggestions, like I mentioned. Generally, we think that the request should be ordered sort of how they are executed in the block. The inter-request ordering should be done by how it's executed in the block, but it's open to the requesters to define. That's up to the request authors. Okay, why even bundle these requests in the block at all? We've sort of been talking about requests. They should be in the block. Why do they even need to be in the block? This is a question that we had actually just a few weeks ago when we were talking with Felix about it, and it wasn't immediately clear why. It's one of these things that we do. We include things in the block. If we care about it, we include it in the block. It seems very simple. No one ever questioned why include it in the block. We finally did question why we include it in the block, and then we looked into it. And it's kind of possible to include this in the block, but what we ultimately found is that to do so would require quite a bit of extra engineering to keep some data around. I won't go too deep into this attack, but basically there's a situation where because we have these two different pieces of software acting at the same time with the consensus layer and the execution layer clients, if they get out of sync, the consensus layer client might optimistically start accepting blocks that it's seeing come over the network. But because the validation of the execution layer portion of the block is like a dependency of every consensus layer block, and if you have just switched to a new branch of the chain where the execution layer is out syncing that branch or doing some other long running process to get itself up to date. The consensus layer, it's possible that it would accept some blocks optimistically, and then the execution layer wouldn't have held around this request data. Because it's not in the block, the execution layer can't just jump back to that block and say, okay, let me look in the block and see what the requests were and see if that matches what the consensus layer thought. To get around this, you would have to add some additional sidecar mechanism outside of the block that the execution layer is holding around for some period of time that just stores exactly this request object that we've sort of defined in 7685. At that point, the question is like, okay, well, why do we not just put this in the block? Like, if we have to do it outside the block, we don't have the infrastructure for that. This is something we have to add to the database. We have to add too many different methods. It's a huge type of reorganization of the code base. So ultimately, even though it's maybe you could say it's a bit more inefficient to also store this request data, we're moving to a world where we're going to be expiring history anyways, so it's not really going to be a huge loss in the longer term. And in the shorter term, it provides a lot better simplicity for the protocol and for the developers for Pectra. Okay, I think that is 7685. If you have some questions, I'm happy to answer them. We might have set a record for one of the fastest PEEPanEIPs. I don't know.
Thank you so much. Thank you for this sweet presentation and talking about like what is request, why we need this, use cases, specs, and specs in one slides. I hope the code base that is getting into every client is also like less characters, and it would be like, okay, this is just 1 line or 2 line change. I'm not sure if it is like that or not, but yes.
Yeah, it's a bit of a change. I mean, it's not that a crazy of a change. Like we have to define the general purpose type for requests. That may not have been something that needed to exist before if we hadn't implemented the request. But the big advantage is that once you have that, which is maybe a 200 lines of code, it's pretty straightforward to add more requests. So it's like big upfront effort, and then afterwards, like very little effort to add more. Whereas if we wouldn't have done this, then it would just be like linear cost every single time we want to do this.
That means we are trying to save developers from technical debt that could come in the future. So it's kind of
Yeah.
foreseeing everything here right now. Cool. And by the way, I think all those 3 proposals that you mentioned are already as like included, and I can see them on DevNet 1 spec. So yeah, it's good to know that there are proposals which could be supported, or there are multiple proposals, but we are trying to still come up with a general purpose spec that could be helpful for handling such requests.
Mm-hmm.
You have mostly answered questions that I had on my mind earlier, but I would still like to take a few more to just get more explanation on things and
Yeah.
how things moved forward. So, would we consider that as the main motivation behind the creation of 7665? And could you maybe even talk about any technical challenges that you might have faced while implementing this in the client?
Sure. I mean, there are two like big reasons. One is like I mentioned the complexity of ordering the changes, because if we have three of these request types, we can't try to implement like say a consolidation request until we have implemented the other requests. Like the ordering in the header matters a lot, just the way that like you do conflict resolution in Git and the way that like we've laid our data structures out. There's not really a good way for us to like if there's 10 elements in the header and we add an 11th, we can't add an 11th 3 different times. We sort of have to like pick like, okay, we added 1, 2, 3. So that added like quite a bit of dependency on implementing those other request types. And that was, immediately something that I found like frustrating as one of the people trying to implement the Pectra EIPs first. It's not really how we tend to work. We tend to sort of implement each individual EIP for a hard fork independently on top of whatever like the latest and greatest is on our master branch. So that was something that was immediately like this code smell that felt a little bit weird. And the second I think is like maybe more just this aesthetic reason. It's funny because on the execution layer, I think we have a very different sense of aesthetics than maybe the consensus layer does. And as an execution layer developer, just like looking at the header, I feel at least you want all of the header elements to be kind of meaningful. And if there's a world where we have to add 3, 4, 5, 10, 15 elements that are very similar, this is something that feels like it fits very well in this like general purpose bus. Like the analogy between the transaction route and the request route, I think is very nice. And honestly, same with the receipts route. And so like for those aesthetic reasons, like beyond just the maybe some of the complexity from the engineering standpoint, like this just feels like it's more right. Also, if you think about what is a request, it's a message from EL to CL. It doesn't really matter to the EL that much. Like we are doing a little bit of processing to propagate that data to the CL, but this isn't like a first class citizen of the EL. It's not like a transaction. It's not like a fee market value. This is just kind of a courtesy element that we're providing to the consensus layer. So for that reason, it's kind of nice to just throw it into a box and then like toss it over a cliff and like let the consensus layer deal with it somehow. And we've just like built a nice little corner for it in the header.
Right. I mean, this is always good to move a few extra steps to save miles that could come in future, and it is just for like making things easier. I understand there is no changes to a CL client, especially with respect to how they are saving these messages. I wonder if there is anything about this proposal that CL team needs to be mindful of, because this is basically an EL level proposal.
Yeah, exactly. So the thing that the CL teams need to be aware of is they need to be aware of the engine API changes. And that's not really spec'd in the EIP, and that's kind of by design. We've sort of created this engine API as this out of protocol, in protocol, DMZ area of communication between these different pieces of software. And so there is like a very specific way that we've defined how to communicate that request information back to the consensus layer. And so that's like what they really need to be paying attention to. I don't think that it matters too much to them outside of maybe for aesthetic reasons. I know that some people feel that the execution layer header should match the execution payload header in the consensus layer or some of these other things. And I can like understand these arguments as like someone who appreciates like a aesthetically pleasing looking object definition. But outside of the like aesthetic, I don't think there's like a technical reason that we on the execution layer in our header have receipts route and they on the consensus layer have broken out each request into individual elements. That was kind of just something to provide flexibility for them, because I don't want to impose as an execution layer team, like we're not trying to impose like how consensus layer teams decide to define. And that's sort of why I meant we have different like aesthetic preferences. I think for us, we like to combine the things into individual fields when we can. We've done it with this transaction type. And for them, they are happy to have like many different fields in their block struct, and that feels better for them.
Absolutely. I mean, I understand these two layers work in parallel, but they have their own independence to decide how they want to spec their specs. Other than this static improvement that we are trying to provide here, are there any major changes to existing architecture because of this proposal?
I don't think so. I think the reason we have this general request object is to avoid changing the block header and body within clients. So people who are consuming and using those types of data are going to now have different pieces of data. And that is something that sort of is propagated throughout the code base a lot and through the APIs. So it will be noticeable. I think in general, like I said, this data is not going to be consumed from the execution layer much. Like if you cared about an exit that you made, you would probably be looking at the consensus layer to see how that exit is processing or how your deposit is processing. You wouldn't be querying an execution layer block as much. So I don't think that there is going to be huge changes for most people.
That's good to know. And talking about like who would be affected. So I'm trying to understand the main user part. You did mention about the proposal being compatible with the future request, and we could find it way more helpful. So I'm trying to understand here, like who will be benefited the most with this proposal? And can you maybe talk about some practical use case of this proposal or the application where people can use this general purpose execution layer proposal?
Yeah, I mean, I think the biggest beneficiaries of this proposal are one, execution layer developers who now have a bit more maintainable way to describe requests, and then two, app level developers who would be proposing request types. So if you're building a liquid staking token, if you're building a restaking platform, anything that's sort of sitting on divide between consensus protocol and application, those are the types of projects and developers that could benefit from requests, because if we didn't have 7685, then them proposing a request, it might be like less palatable because of how much more work would be required to add such a request. Whereas now adding new requests is kind of trivial. It's about as trivial as adding a new transaction type, which is easy to do, but a lot of boilerplate code, still, even with all the nice abstractions that we have. But yeah, I think that that's the type of application developer that would benefit the most. In terms of like the people impacted the most, I think those types of developers, but also anyone who is developing libraries that interact with clients. I think people who are doing Ethers.js, the people who are doing, I don't know, whatever the other trendy JavaScript libraries are, they're going to have to update their libraries to now support or properly decode this new data in the JSON responses from clients. But
That
end
is
users, more or less, I don't think that unless they want to access that data for some reason, they have a purpose to do it, they're not probably going to notice or see anything related to this.
That's always good. Like when we are making some changes to the Ethereum mainnet, it is like always helpful that the end user may not have to look into too much of details, but it's good to know that what can be use cases, what other applications can be thought of making use of these proposals. Very well. I'm now trying to understand about the development of this proposal. So I noticed there was a decent engagement on the FEM page for this proposal. If you
Mm-hmm.
would like to maybe talk about the feedbacks received from developers and community, was there any significant comment feedback that may have prompted you to make any specs changes to the CIP?
I think there was some feedback to clarify some things that weren't super clear. I think ordering was one thing that I did add some clarifications to. But in general, most of the feedback was generally positive, and the only negative feedback received had to do more with timing because this came about attempted implementation of the Pectra EIPs for DevNet 0. It was pretty late in the process to try and push through 7685, and so there was questions like, should we just go ahead and do DevNet 0 as it already was agreed upon and then do 7685 afterwards? And I think we were able to come to an agreement that it just makes sense to do 7685. We're probably going to want it, and it's going to minimize like how much duplicated effort we have to do. But I think that was like the one needle we had to thread.
It's good. And it's great to know that this is already in the DevNet 1 spec. So we are sailing smooth. Yeah.
Yep.
All right, let's talk a little bit about security consideration. The proposal says that it needs discussion. I'm curious, where can people or interested parties may participate in this discussion? Is it the Fellowship of Ethereum Magician, any particular Discord, Telegram, or core dev calls?
Yeah, it would be great if someone has a security consideration to post about it on the Ethereum Magicians forum. So far, nothing has come to my attention that we should be concerned about, but maybe someone has a concern out there.
Great. If there are no concerns, perhaps we don't need any measures to prevent from like any kind of issues. We need to see the issue first, foresee the issues first.
Yes.
Very well. I know you are an EIP editor, author, client developer to implement these proposals. And as I was mentioning, also you were on our first episode to talk about the basics of making an improvement proposal or how to write an EIP efficiently. I would love to hear your advice at this stage for other developers or teams who are looking to propose or develop their own EIPs. Yeah, what would be the key ideas that you would like to communicate for people who would want to write and take the proposal to the final status?
Yeah. There's probably a bit of a function of having been here for, I guess, 4 years now. It sounds like a really long time. It's insane. Actual mechanics of the proposal feel simple now. And I know that like for people coming in, it's still this black box. And so I recommend like step one, understand what an EIP is, understand how to write an EIP, the structure of it. These things are pretty well documented. You have created a lot of content about it. We had a PEEPanEIP about EIP1. There is EIP1 to read. Like, I think that that information is well covered. It's out there. And that is step one. Like, you have to really understand how to write it and like what they look like. And I recommend looking at some like good EIPs, some EIPs for Pectra, probably some EIPs from Cancun, just to see like what does a finalized EIP look like. But that's like, the pre-work. That's the minimum to like come to the table to figure out what you want to do. And so now that you sort of know how EIPs work, I think the thing that isn't less well understood about what to do afterwards is how do you get engaged with the community and the core developers. And that to me is like the really interesting thing these days is like, and the thing that I'm noticing is like the big disconnect, because there are teams that are very sophisticated and have been around for years, and they like definitely know how to write an EIP, but they don't understand like how to get engagement with the EIP. And there's two things that you have to do to get engagement. One is you have to come to the calls, the all core devs call, the breakout calls, if there are like breakouts relevant to this topic that you want to discuss. Because if you're not coming to the calls, there's no way for you to communicate this idea. I think like if you post on Discord in the relevant channels, R&D Discord, that's a good place to start. But like ultimately, we have created this period of time every 2 weeks to discuss and hear the important proposals. And not only will that give you a platform to potentially propose your thing by communicating on the agenda somewhere that you want to propose it, it will also give the proposer an idea of what is being discussed. Like right now, as an outside person, you might have no idea what's going on in these calls, but I can tell you that if you were to come to propose something for Pectra today, it would be hard because we have already like sort of been talking about what is going to go in Pectra since January. So that cycle has sort of ended. And now we're sort of in this like period, this like lower period of time of activity on the call where we're focusing on developing Pectra, getting the testing ready for Pectra and launching it. And then in, I would say 6 months, we're probably going to start again talking about what's going to go in Osaka, this next hard fork. So as a person who wants to contribute, it's really important to sort of understand where in these cycles are we. And we on the core dev and protocol governance side of things are trying to do a better job about making this information more visible, communicating it better, because I don't think that just telling people come to the calls and figure out what's going on is like the best feedback you can give. But we're making baby steps. So I think if you come to the calls, that is the right platform to make a proposal. I mean, you should probably have talked to some people and make sure that this idea is something that makes sense. There's nothing worse than someone coming to the call for the first time to propose their thing and all the core devs just being like, what the fuck is this? Like, where have you been? So do your due diligence and make sure that it's not something that has already been proposed or something that makes that probably has no chance of getting included. And, then you have to come to the calls and talk to people. And it just means that at this point in time, it's not the most important thing for the core devs. And I think that like history expiry is a good thing to illuminate that aspect. Like history expiry is important objectively. Everyone agrees upon this. We've agreed upon this for 2-3 years, but it's just not the highest priority element of the core dev like hierarchy. So for that reason, it just sort of sits there and we don't really talk about it. And then sometimes we talk about it, but we don't really do anything. And like if you come on and you have a proposal that like sits in that category, then that's just how it is. You can't force the core devs, the client teams to prioritize something if it's not the priority. And that's kind of the beautiful thing about Ethereum is like we have all these people and these teams sort of working together to create this priority map. And it's kind of messy and ugly at times, but that's how we end up deciding like what goes into the fork.
That's the beauty of the biggest decentralized community. I mean, there are so many good proposals. It's very hard to like define which should go in and which should wait. And definitely priority takes priority over there. And then we have to decide on list of proposals. Well, for people who would still be thinking about adding proposals to Pectra, my sincere request, please do not. The giraffe is already very tall here. We have 20 plus EIPs, so it's already the biggest fork of Ethereum so far. And we hope that this goes successfully. And this is already on DevNet 1. Hope to have a few more DevNets before it goes on to public and then finally on the mainnet. May I ask about the timeline? When do you think that we can expect this Spectra upgrade on the mainnet?
That's a great question. I
Maybe you can
think
give the answer from client team perspective and EIP editor perspective and maybe just a general user.
I would have liked to have a fork this year. That was my original hope. I don't know now that we are staring down the largest fork in Ethereum history if we will pull it off this year. I'm feeling a little less optimistic, but we'll see. Like the original target that I had in mind was sometime early November. And yeah, I mean, we're 6 months away. It's possible. I think with adding EOF, that's going to push us back a bit. And again, like I'm only talking on the consensus layer side, or sorry, on the execution layer side. I really don't have a great idea about the readiness on the consensus layer side. But as of like 2 or 3 months ago, that's what I was shooting for, and that's sort of like what the timeline I had in my mental map. But now I'm like kind of open. We're just trying to hustle through these dev nets and see what happens. So we should have a much better idea in 3 months if it's going to be this year, if it's going to be sometime next year. But it would be great to have a fork this year.
Yes, of course. We are expecting DEF CON in November. If it would be around
Yep.
that would be fun to have.
Yeah.
Very well. While I have you, I know you were there on the first episode, and since first to this 132 episode, I would love to hear your thoughts, feedbacks, and anything that we can add, remove to make PEEP and EIP series even better for developers, especially where we are expecting these episodes to cover proposals which are getting into network upgrade, how we can make it even better for developers.
Yeah. I mean, that's amazing that you've made this many episodes. And I think like in general, the episodes have been super high quality. Uh, I get that like we are kind of a niche audience. Like how many people want to hear about the general purpose request framework for the execution layer? There's not a lot of people out there, I think, that are like super interested in this content. As a core developer, I'm very interested in this content, and like sometimes before implementing an EIP, or if I'm trying to catch up on something that's like outside my domain, maybe like inclusion lists. Like I have listened to some of these PEEP and EIPs because this is sort of like the most dense, rich place to get that type of information. So in general, like I think PEEP and EIP is super awesome. I've been like really happy to see that you've like been making sure that all of the EIPs get discussed, and not even the EIPs that are just in this hard fork, but just generally the EIPs that are garnering interest. That's been amazing. Feedback, things to improve. I think it could be nice if it was easier to access like the denser parts of the videos. Like, and that's just hard with the video format in general. Like you have this like longer form piece of multimedia. It's hard to like extract that information into like a text format or something. But if there was a way to like take those learnings and like put them in a place where like it was in the I mean, you do post the peep and eeps to ETH magicians on the thread, which is useful, but if there was like takeaways from the peep and eep, I don't know if you've been doing that lately. I feel like usually it's just a video link, but I mean that's a lot of work. So I get that the video is already a lot of work, but if there was a piece of feedback, I think that being able to synthesize more of the information in the video, because like I've just been rambling on, I probably said like 5 useful sentences this whole video, and if we could just like put those onto the notes in the ETH magicians thread, that's something that might be useful.
That's a very valuable piece of advice. Yes, I understand that with the content of about an hour, it could be sometimes overwhelming for people to like, which portion we should watch specifically of our need. We are trying to add timestamps that could be useful, but it's a good idea to maybe share about the takeaways. We do plan to come up with small quizzes to maybe help people understand these proposals even better, called Learn to Earn platform we are working on. And there we try to come up with like 4 or 5 questions related to this or any proposal or which are getting into any upgrade. I hope
Yeah.
that would be helpful for people to even get it faster.
Yeah, maybe one other idea, and this is like starts maybe to move a bit away from this like format that you're cultivating, but I wonder if there is an audience out there that's like more audio heavy, like podcast type of audience, that if you're like leaning into the idea of like guests bring slides on, that they might not get the same, if there's an expectation of having slides, this was a very audio text heavy thing, but like some people probably come on and have a lot of diagrams and things, and that would be hard to communicate to an audio audience. So I don't know, like if you were interested in unlocking more people, that might be something to like try and focus more, like less on slides and more like let's make sure that everything is digestible for an audio only consumer. That could be interesting. But it's also hard, like if we're talking about really technical topics, it's like difficult sometimes to actually communicate those ideas over just sound bites. So I wouldn't say that these are things to change, just possible ideas, things to consider.
Yes, appreciate your suggestions. Yes, we are trying to post a audio only version of this every episode on eCat Herders podcast. What we do additionally is like in resources section, we try to add the video link and the presentation link. So even if people who are listening to it and want to refer to some details, they can just follow the either the video form or the slides link there so they can understand. It is sometimes very difficult to get into understanding of proposal without any diagram, because sometimes block and diagrams are way more helpful than the actual specs those are getting in.
Yeah, totally.
So yes. Well, we will try to continue making it better and try to improvise, and maybe in advance, if we can let the author or narrator know that we are making an audio version of it, we can get it more verbose, and that would be helpful for our podcast listeners.
Yep.
Thank you so much, Matt. I really appreciate it. And I think it's time we should perhaps wrap up. Thanks, Matt. I'm really grateful for you to take out time and talk about EIP 6785 with us. Glad to see the proposal is already on DevNet 1, and we are looking forward to see this thing deployed on the mainnet. For viewers and listeners, please let us know your favorite proposal for the Pectra upgrade and why do you like that proposal. You may also follow description to get author's detail, and you are welcome to share your thoughts about this proposal in comment section. Talk about what do you think about PEEPanEIP in general, and as Matt was mentioning, if you have anything to add for security consideration, please come and let us know at the Fellowship of Ethereum Magician. That's going to be super helpful for developers to consider at this point of time, so we can do any measures that is required to prohibit your project getting into danger. As promised, we'll be back again with another episode of PEEPanEIP. Till then, keep watching, keep listening, and keep sharing your love with Ethereum Cat Herders. Thank you, everyone.